Alright, so in this video, what we're talking about is oxidative cleavage. Okay? So if you see something, if you blank on the exam and you see something with heavy amounts of oxygen like KMnO4, there's 4 O's, just think of oxidation. Okay? So what's going to happen is you're essentially going to cut the double bond in half. And the way to do this is that each side of the cut gets an O. And I kind of over-exaggerate that, but if you have a double bond and I cut it, each side gets an oxygen after that cut. So you create carbonyls. So you cut it and just write an O on each side of the dotted line when you cut it in half. If you have multiple double bonds, like if you have, and this is getting really congested now, but I would just cut both double bonds, just for an FYI. Okay? I know all these examples only have one double bond, but if I had multiple double bonds, I'd cut all of them. Okay? What I want to keep an eye on is the hydrogens that are coming off of an alkene, because that's where there's differences in reductive conditions and oxidative conditions. So this, you agree, is a hydrogen coming off a carbon that's involved in double bond or an alkene. If you see ZnHOAC or CH32S, that's what we call reductive conditions. And your H, when you cut this again, you cut it, you put an O on each side, right? So it forms carbonyls, it stays in H. It's called reductive conditions. If you see H2O2, you oxidize the alkene H's. So instead of H, it becomes OH. And once again, you draw a dotted line in between the double bond, and you put an O on each side, which is why you have 2 carbonyls. There was no H's on this side, they're both C's, so they stay as C's. But yes, you've cut the double bond in half. That's all that happened. So what did we learn? We just learned oxidative cleavage is alkenes. You're going to learn the same thing for alkynes, by the way. You cut the double bond in half, O's go on each side. Keep an eye out for the second, this is all one reaction. The second step will tell you reductive conditions or oxidative. And that really only matters for the H that's bonded to the carbon that's involved with the double bond. If this H and it's reductive, it stays in H. If it's oxidative, it turns into a OH. Woo!